Hey everybody, it's Norm from Tested.com.
And Sean from Tested.
And hopefully by now you've seen our reveal of the Ghost Trap project that Sean designed and made. Truly incredible.
It was quite the ordeal, but I am really proud. It's probably the biggest project I've ever tackled.
Well, you spent a couple months thanks to Dremel, which gave us the opportunity for you to design and build this out to replicate the Ghost Trap from GhostBusters 1/2, a hybrid trap, to something that is 3D printed and fully functional.
Yes. So the original intention was we were going to fully 3D print a ghost trap that you could print like fit everything on the print bed and do it completely except for the screws. But then, it's like, well, it'd be nice if it actually worked. And then it kind of just kept ballooning from there till we ended up with the deluxe trap where it has as many real, accurate, or metal parts on it as possible. So it's got like the aluminum plates and knobs and all the details like that, and it's fully functional.
So let's demonstrate that functionality for people out there who may not have seen it yet. You got to flip it on first.
Yep, so we got the power switch up top here.
Okay.
It's ready to go. And it can be, I should point out, it can be triggered from the pedal, which we've done, or from the trap itself. There's one of the knobs that is wired so that you can do this standalone as well, because it's all, the electronics are contained in here.
All right, you got a ghost hovering above. Captured it.
Captured.
You got flashing LED lights.
We got smoke.
Smoke, and then indicator says that the ghost is now trapped.
Yeah.
That's incredible.
So, and then once more the reset.
Awesome. Well, today what I wanted to do was just talk through with you your whole design and build process, how you source your reference, how you came up with this design to be a kit that can be 3D printed, and how you collaborated with Jeremy Williams for the electronics and all that functionality. Let's start with the design.
So, when you're replicating this stuff, a lot of times there's a trap that only opens, there's a trap that only has light, there's a trap that only has smoke. This had to do everything packed all in here. So some people have done ones where the cartridge comes out, like if you're going to put it in the containment unit. I decided that this would just be all one piece because it would just make it too complicated for what we wanted to do. So we knew we wanted lights and sound for sure. That also meant that the doors had to open. And then I added a holy grail wish of adding smoke, which was kind of, it came in at the end, but we got it done. So there's a lot of electronics and stuff in there, a lot of mechanics. Figuring out the door mechanism was a challenge. Figuring out how to get the pedal to trigger this was a challenge, because these are pneumatic air connectors, which are not really meant to pass wires or electrical connections. So originally we were going to do wireless, and that ran into a bunch of problems. So now it's hardwired. So it was tricky. So during the process, what I did is I tried to get as many real parts or accurate parts to the actual ghost trap as possible. A lot of information. Mark Dubois, from Tippett Studios, directed me to some sources such as GB Fans, which is gbfans.com, dedicated to everything Ghostbusters. An excellent source of like, this is the right part for that, whatever. They even have some stuff. They have a little shop set up where you can buy some things, and there's certain things like certain decals that I bought from them are other really, really hard to find parts. But there's a lot of stuff that I sourced myself, which was probably a solid week of looking at parts and making notes and getting it all put together.
Well, Ghostbuster fans, they have an affinity for maybe one or two, and like you said, the prop makers made actual different versions of the Ghost Trap. Like when we saw when Prop Store of London had one at Comic-Con, it was specifically one from Ghostbusters 2 that worked at a specific purpose and function. Now, when you want to identify and you look at this trap, can you point out some of the things that people can recognize?
Well, let's be right up front. This is a total hybrid trap. Looking at all of the references and photos and hero traps and stunt traps, everything, it will make your head spin. And there's even debate in the community, like, what was on what or whatever. And like the screen grabs that I was getting, that I sat down and got directly from Blu-rays, sometimes would seem to contradict what I'm seeing that the forums are saying. So I started to get really overwhelmed. So I made a decision to do a hybrid trap on purpose. It's kind of a cross between 1 and 2. The overall dimensions are from 2 because it was a slightly smaller trap because the actors were complaining about size and weight. So overall dimensions, in order to fit on the print bed well, everything are a 2.
Okay.
A lot of the knobs and screws are based on 2.
The greeblies, yeah.
Yeah, now 1 starts to creep in there. I love the red side rods in 1, which are silver in 2. I just like the red ones.
There's
So
a
I
good
put
contrast.
this
Totally.
on. The cartridge, so what comes out and goes in the containment unit, sticks out on the 1 past the front of the trap. On the 2, it typically was flush, and I like it sticking out a little bit like that, so I made that change. So, like I said, it's drawing from both.
Cool. All right, so you took your screenshots, you actually printed out some of the images you found blueprints, annotated them to hell. I'm looking at your documents here, and you're identifying not only the individual pieces of hardware, you're circling like, what is that piece and what is that piece? And obviously, with the forum help, you're able to identify what that cover is, what that is,
and some
what this ribbon is.
Some things I was able to get exact part numbers on the forums, some things not so much. And there was a lot of like my own searching that I did. For example, this relay, which goes on the pedal. The original is an Italian relay. You cannot get these. If you find it, it's like $85 to $100. Wow. Even a regular old relay, which these are close approximations of what the original was. Even these like new can run anywhere from $18 to $50. So, and they typically, the real one is an 11 pin, but there's a lot of 8-pin ones out there. So I bought a mix of both, and I got the correct sockets for both. In the 3D printed version of the pedal I did, which you don't have out right here, but I made 3D printed versions of the 8 and 11, so you can you can bend the rules a little bit.
Yeah.
Like I thought I got really lucky. This, the resistor, which is super hard to find on the original, I found a box of these at a flea market in the East Bay. Wow. I thought I hit gold. They're not quite right. I thought, it's not quite. The fins aren't in the right place. Yep. So sometimes you think you get really close, and you got to go back to the drawing board. It's
one of those things where you become so obsessed with the exact parts that you can walk by an electronics flea market.
Oh yeah,
and you know the resistors. You know maybe they have buckets of resistors at the store. Yeah. And then this jumped out at you. Yeah. And it's close.
Close, but not quite. So and there's these are project boxes that you can just get off the shelf that are reasonably priced. But an advantage to 3D printing them is that when you 3D print them, it has all the holes for all these add-ons in exactly the right place. So that makes things so much easier. Now what I did for these is I made little fold-out templates that I 3D printed, and you can fold around these to draw the holes where they should be if you're going to use the real boxes.
I like that it's not just a respect for the original components, but the way you designed and modeled the 3D printed version, it's not a singular piece. It's modular. It's modular in the sense that that's how you assemble it, but also in that you can swap out some of these plates, almost any of these pieces.
Yeah, so you can kind of do incremental upgrades as you get the real pieces if you want to do that.
Find the right handle, then you can remove your 3D printed handle and put the right handle
Exactly.
in.
So, and that's a good point. That leads into when I designed this, I kept all of these parts were designed with real world parts in mind. So for example, the handle, I modeled it based on an actual tubing size so that instead of having a 3D printed handle, you could swap out this aluminum handle and kind of have an upgrade. The side panels, I made 1/4 inch so that you could CNC these out of MDF if you wanted to, or use some other material. The aluminum side plates, the 3D printed ones, are based on the actual thickness of aluminum that I used, so you could swap them out. And another nice thing is you could 3D print the plastic side panels and use those as templates to make the metal ones. So it can go both ways.
So Sean, I wanted to ask you about the software you use, especially the modeling software. How did you turn photographic reference and blueprints into a 3D model, then which could also be broken down to be 3D printed?
Yeah. So typically with this type of project with a lot of intricate mechanical pieces, you might want to use CAD, such as SolidWorks or Inventor or something like that. I'm still using Polygon modelers, Cinema 4D, which is similar to Maya, used a lot in animation and the entertainment industry. And you can model in exact units in that, and it works for me. I make it work. And sometimes certain things are easier to do in that, certain things are harder, but it all works out for me. And basically, I had blueprint references that I got from GB fans, from Sean Bishop and Stefan Otto have sets of amazing blueprints that they have drawn out that I use as a starting point. Some things, since there's a lot of real mechanical parts on here, I was able to find blueprints from the actual manufacturer and use those to basically trace over so that they're super accurate. Sometimes I was even able to find actual 3D models from the manufacturer. So the project boxes, they actually released the 3D files and I modified them to work with the fully 3D printed
That's unbelievable.
pedal. Yeah.
That's a source part that you could buy the part, but they actually have the model, which then you modify and add the screw holes,
Yeah.
and you can print out.
So modified it to work for our project.
So you have your knobs and dials, which you sourced and you found them, and then you modeled them to be
Yes.
printed. So when we look at the 3D printed version, you have like the proper knurling, the dials that fits here. You could buy that, or you can 3D print that. That's an individual piece.
Right.
Now, when you talk about the side panels, though, it's not just the structural. There's actually functionality in the side panels that you modeled inside. So can you talk about that?
So yeah, there are other 3D printed ghost traps that I've seen out there. The thing with those is if you looked at the side panel, everything was just globbed together in one piece, so it prints out as one whole piece, which makes it terrible for quality of print because not everything's optimally oriented. It makes it hard to paint things because you got to make sure that nothing gets on everything else, and structurally then you could have some issues. So inside we have a whole frame that these screw into. It also allows structure to put the electronics.
Right.
There are special pieces that were modeled and put together for the door mechanism, which we'll go into a little later. And there's special pieces back here that, such as the rear panel is a magnet that comes on, so there are magnets mounted in there. And so each piece is kind of specially modeled to serve a particular function.
Yeah, and function really is what separates this ghost trap from the ghost traps that other people may have designed. It really is a step above. And a lot of that functionality came with a collaboration, you and Jeremy Williams. So we're going to bring in Jeremy to chat with you about how you work together to get the doors working, the smoke working, and those lights and sounds.
Yeah, because this wouldn't have happened without Jeremy. Okay, we're back with Jeremy Williams, who helped me greatly on putting together all the electronics and doing the programming for the ghost trap.
My pleasure, my pleasure.
Because this wouldn't be as cool without you. So the overview of what we did is I thought that we could maybe use an Arduino, and we ended up getting almost all of our parts from Adafruit, which is one of our favorite places to get electronic goodies from.
Yeah, that's where I shop basically for everything.
It's great. There's only a few things that I couldn't get, a few LEDs and like the toggle switch, but everything else in this guy is Adafruit. And so it's got an Arduino buried in there. It has the super high power LEDs for the top. There's 3 of them along here. And I have basically just a lighting gel in there to get the correct, it's kind of a pinkish color for the ghost trap. And we have a little mesh grid in there just to make it interesting. And we have the smoke thing, and we already talked about how there is a pipe that is 3D modeled into the ring here, and then outlets for the smoke.
I love that aspect of this design.
That's a perfect example of how 3D printing can like do things that would be really, really hard to do with just traditional manufacturing. Because a lot of these, you can make the side panels, you can make the doors, no problem doing CNC or even hand making it, but something like that is where the 3D printing can like really bring you things that
and it's important because you have to route around this gel that you have in here. It's not like the smoke can just come up.
Yeah. We did things like, so the back panel here is magnetic, so that it can be removed. And in here, we have a 3.7 LiPo battery, also from Adafruit. And we have a boost board, which brings it up to 5 volts so that it'll run all the Arduino and the other electronics.
So Arduino is a 5 volt, a platform. So we had to use this boost board, which gives you 1 amp at 5 volts, coming up from the 3.7. I was thinking initially maybe we should just stick with a 3 volt platform.
Right, and
because we
maybe
were going,
a different controller.
Right, because we were going with this 3.7 volt battery, and we would stick at that sort of native voltage. But you had some other 5 volt components in here, and it just seemed like there'd be fewer adapting steps if we just went 5 volts.
And so what I tried to do, I tried to pack all the important stuff in the back box here. So you got where you can plug this into charge. We have the battery. We can remove the smoke mechanism to refill it or recharge it. So all the important stuff is right back here in the box, which was nice. And then let's flip it around here, and we have the guts. So there's a lot of stuff. I thought we had plenty of room.
Yeah, well you did. You did before there were wires in there.
And then it just started to get to be more and more things. So we have the Arduino with a music shield that's stacked on top of it for the sound. We have speakers and lights mounted to the top plate here. We have the air pump for the smoke. You can just barely see the e-cigarettes sticking down here, so you can take them out. And we have our power rail. You suggested making a power rail so that we could tie everything into it. So.
Everything there is 5 volts.
Yeah. So there's a lot of things that I was like, I think this will work, I don't know. But then you came in to help advise. And why don't you talk about the programming a little bit? Because I basically gave you a reference video from GhostBusters. And I gave you kind of a written, this is how I see the sequence. And we did like, I was worried about getting a little too grand, so we did like a real simple version, and then we did a more deluxe version, and I think we actually end up pulling off the deluxe version.
I think so too. The smoke, I think, is the key component from the deluxe version, that you really found a way to get that working. It was no trick from a programming standpoint, but I also want to point out, you didn't just give me a sheet, you gave me this basically with most of the wires like ready. You gave this to me wired with labels and tape and ready to plug in.
I am good at wiring.
To an Arduino. It was immaculate.
Thank you.
It was extremely helpful, and I loved working on this for that reason, because all I had to do was program. Like there was,
that's all.
There was very little engineering that I had to do besides adding a few transistors, because for instance, some of the LEDs, they won't run on 5 volts. Or they would have pulled too much current from the Arduino, so we had to run them directly off the rail. And
that's where you're vital for the electronics, because that's the stuff that I don't know enough about to figure that part out. So that was a great collaboration.
Yeah. So like the 3 flasher LEDs, and what else? Is it the motor or the smoke machine?
Yeah, we put a transistor on the
Those
motor.
all run on a transistor, which basically acts like a switch. So the Arduino sends a signal, and it just opens up the current from the 5-volt rail.
So that's where we can get the flashing of the lights and all that stuff.
Yeah.
Why don't you talk about the bar graph? Was one of my major concerns for that. There's this little bar graph here that fills up, and Adafruit ended up having a very cool little component that fit that bill.
Yeah, that's exactly what they call it. There's a bar graph. There's a library for it. It can be 3 different colors, but we wanted it to be yellow.
Like yellow.
Yeah.
It's a little orangey yellow.
Right. It's not perfect, but it's the right size. It's pretty good.
Yeah.
So that control board is right here.
Yeah.
So it requires just a few cables from the Arduino. Otherwise, you'd have to run wires for every single LED.
We should point out that the way this is supposed to work is the bar graph is supposed to be hardwired to the board that's right here.
Yeah.
And it accommodates 2. But I realized that there's going to be no way to put that up there. So I ended up, it was the most terrible wiring portion, wiring all the individual wires to the pins and then running them the whole way to the board here. But it worked.
You should mention this wire. I guess this isn't the silicone wire.
Yeah.
But this is, and it's wonderful.
Oh my God. I mentioned in my favorite things video, this silicone wire that Adafruit's been carrying is amazing. It just lets you, when you have to pack this much stuff in there, it made things so much easier.
It's very flexible.
But in this case, this is the first version of the bar graph they did. Even this was a little too bulky because it has to fit in with the mechanics of the door.
Yeah.
So this is just some miniature flex wire that I used for that worked really well.
Yeah, it's good because it's small.
Yeah.
So you asked about the programming. It's really, really simple. It's just the trap goes through different phases or states, probably is a better word, where it has to know what sound file to play, and then it checks to see if that sound file is finished. If it does, then it enters a new state. With this soundboard, you can actually play sounds in the background while you do other operations.
Which was really key for
absolutely,
our
because
setup.
that allows us to make the lightning sound effect while flashing lights. Which is something that you could only do with this music board for the Arduino. You wouldn't be able to do that natively.
Because otherwise it'd be like, okay, you can play the light, then play the music, which would just take away from this.
Yeah, so there's like 4 or 5 states it goes through, and then it just, as it gets more input from the button, and there's only one button.
And the way Jeremy set it up is that for each pedal push, or the way I put this knob on, for each turn of the knob, it triggers the next thing. So the first pedal push opens it up and the lights play. It'll do that for as long as you want until you hit it again, and then it closes and does the closing sequence, and you hit it again and it'll reset. So.
You mentioned that we tried to go wireless with the pedal, which would have been great because...
It seemed like the perfect answer.
Yeah, and it's RF. You would think, okay, that should be able to go 15 feet, let alone 6.
Little board to put in the trap.
Unfortunately, this is sold by Adafruit. Most of their stuff is fantastic. This, I didn't have the best experience with. It wouldn't go more than about a foot.
Which wasn't going to cut it.
And we're not the only ones who had that problem. If you look on the forum, it tends to be very sensitive to interference. So unfortunately, there's a lot interfering inside.
Because I could not figure a way to use the real connectors and run wiring through them. So we originally had this. It's a clicker, and I had it embedded in the hose and the pedal, and I was so proud of that.
Yeah.
And it seemed like the perfect setup, and it just didn't work. So it was kind of late in the game, and you were like, I don't think this is going to work. And I was like, oh,
please, can we find a hardwired connection, please? And then you did it.
I couldn't believe that it worked.
I knew after seeing this trap you could do it.
So this is the Foster connector, which is a brass pneumatic connector. This is the male. So if you ran wire through this into the hose, there'd be no way to disconnect it. So we had to figure out a way to make this be able to disconnect and still have a contact. So after a lot of messing around, I 3D printed an insert.
2 contacts, because it has to complete a circuit.
3D printed an insert and then put a brass rod in it, which made it a 2-conductor contact.
Brilliant.
Now that was easy enough, but then the female turned out to be a bit of a problem because there is a plunger in here that seals the pneumatic hose when you remove the air tool. So I found out you could take this apart, and and it's spring-loaded, and I was lucky that there's a rubber seal. So I soldered a connector to the middle, and the rubber seal insulates it from the rest, and it made this into 2. I couldn't believe it worked.
And it hasn't failed, right?
I've been really torture testing this, and it's been pretty robust.
That's fantastic.
That's one of the things that I was really proud of. So it is hardwired now, and it works that way.
One other thing to point out is we ran out of I/O on the Arduino board because running that music board takes up quite a bit of pins.
Yes.
We also had these 3 high-power LEDs. We had the bar graph. We had this LED, and the switch that we needed to
and then we added the smoke.
And the smoke. So thankfully, the music board actually comes with its own I/O pins, about 7 of them, I think, 6 or 7. And thank goodness, because we used 4 of them, and they are key to making this work.
It really worked out well. I should also say that Jeremy did some really nice audio editing as well, because I gave him the base files, and I have to thank Frank Ippolito and Jack Dowd, who is Ghost Head on GB Fans. They supplied me with, they were basically music file or effects files from the 2009 Ghostbusters game by Terminal Reality.
Nice.
Terminal Reality released them out into the wild for free. And so I was like, oh, well, that'd be easy to find, because you can find Proton Pack sound effects, no problem. But trap effects were really hard to find for some reason.
That's interesting.
And I could not find these game files. So Frank and Jack both sent me varying different ones of those, and then you further modify them a little bit, fix the levels.
I watched the movie
them.
clips, and I got the pitch closer to where it was.
Yeah, so thank you.
Simple
for that.
editing.
That was going above and beyond. So let's look at some of the details here of like how some of these things are done. So the doors need to open and close, but I don't know how they did it in the movie for sure, but a lot of times, there are tricks that you don't see going on.
Maybe it's mounted to the floor and there's a little puppeteer
or they're spring-loaded and they just pop open and then they reverse the shot.
Exactly.
Who knows? But I didn't want any little rods sticking out or because I felt servos would be a good choice.
Yep.
But I didn't want any rods sticking out the top or anything like that. And there's a very limited amount of space to make these doors work. There's screws in the back that hold them on, and then there's these little wings up front, but there's not a lot of room. So I went through probably about 5 different possibilities of how this could work, and basically what I do is I build it in 3D to just walk through seeing how it would work, and none of them would work. There just wasn't enough room. It just wasn't happening. So I did the Millenbob motivator for the Hellboy glove that Adam did, and in that he had this miniature chain. So I was like, I wonder if that would work.
Is that where you saw that chain?
I ended up using this miniature chain drive to drive the doors. So the wings basically slide on the side. There's axles that go here with little tiny sprockets on them, and there's sprockets here. Now originally, I had this micro servo that had one chain going from this to the wing. And it was too steep of an angle and it was rubbing on the housing and I couldn't make it work. So then I had to end up putting this transfer shaft in and running 2 chains. And it just kept getting...
So it can move from one direction to another.
Yeah, because going this way, it couldn't quite make it. It was too steep.
Yeah.
So I had to go up and then over and it just...
Which adds more friction. You would think it would actually start to break down, but it works great.
These are push-on sprockets and they were working great. I got this whole thing assembled and then they all started slipping. Oh. So I had to take the whole thing apart again and actually put little set screws in all of them, which was a bit of a pain, but it worked. So we can kind of get a demo here. If you want, why don't you hold that and so I have a little servo control board and
so how do you control the length of these little chains?
They're just like snapped together like Lego chain.
Oh, really?
Yeah, so they're plastic, they just snap together, you count how many links you want, and then you just put them together.
And you can, you can detach it just as well in case you want to change?
Yeah, it's hard to snap them together in place, but yeah, you can do that.
That's really cool.
So I was very proud of this. This turned out to work really, really well, and once I got the set screws in there, it is worked fabulously.
And there's one servo for each door?
There's one servo for each door, so this is just one half. There are little slots molded into the plastic for the axles to be held into, and they're basically just loose in there, and the chains themselves actually hold them in position once everything's in place.
And servos are what like an RC hobbyist would use to control steering on an RC car or something like that.
Adafruit had these really nice miniature metal teeth, so they have good torque and they'll hold their position without being constantly sent a signal.
Right, they just need voltage.
Yeah, so I basically put them in, you pull them over to, it has these slots to tension them, and you're good to go.
Oh, you incorporated tension slots.
Yes.
Thanks of everything.
So that was the one challenge. The other challenge that we really wanted to get smoke in there. Yeah. And that was like, I looked at a few different things. I tried thinking using like train smoke mechanisms, like model trains.
Yep.
That didn't quite work. And I thought about e-cigarettes. What about e-cigarettes? And it turns out other people have done that. A lot of them, I learned way more about vaping than I ever want to know. And the really fancy big ones that give you really big clouds of smoke are ones that you typically have to push and hold a button to heat them up, and then you take a puff. I wanted to use these simpler ones that look more like real cigarettes because those are pressure activated, and you just have to
instant on.
Yeah, and they're triggered by drawing on them, so there's less involved. So this is an example setup of how we did. So I have an air pump that has an in and out. We have a basic e-cigarette that is tied to that.
Is this like an aquarium air pump kind of thing?
I don't know what this is. This was actually hard to find. You could find air pumps that just had an outlet, but like an in and an out was harder.
Interesting. So it's sucking in the e-cigarette. There it comes. I see it.
Yeah. So this was my initial test setup, and it was a good proof of concept. This is a really cheapy one, and this one actually has like flavoring and nicotine and stuff, which I didn't want. So I ended up getting these other ones, which are refillable. So to access this, you take off the back panel. There are clips that I incorporated into the frame that hold them in place. And then you can pull the whole thing out to refill it. So I used 2, partly because they get hot when you draw on them. And I was worried about drawing that much on just one and it overheating.
Or having it run longer.
Right, and the quantity of vapor I wanted to worked better for that. So these particular ones that I got are great because you can pull them apart. They have little tanks that you can refill. You can take this and recharge it. And I'm using vegetable glycerin in this. So vegetable glycerin gives you a really nice white dense smoke. And I just have a little needle bottle that you can refill the tanks. Yeah. And you can I was surprised by how many, we've been shooting this off all day and I haven't had to recharge and fill it yet. So
where do you source vegetable glycerin?
Amazon.
No kidding.
Apparently you can get a nice big bottle of it for relatively cheap. Right. And you can use it as a sweetener, you can eat it.
Probably you don't want to smoke it though, right?
Well, no, you can. People use this for vaping, yes. Okay. That's where I learned all this about propylene glycol and vegetable glycerin, I think are the two. But yeah, this is the one that gives you the best vaping. So there's cloud chasing, which is when you build a really big one and make like big dragon clouds.
Okay. Or a GhostBusters trap.
Yeah. So that was and the motor was one of the last things we added, and it was a bit of a challenge getting it all working. But
for you, it was certainly a huge challenge. For the code, it was a simple couple lines. Yeah. But what was a challenge were these flasher lights. Remember at the very end we were trying to get those synced up, and something was not working.
Yeah.
We were trying to use this music board in order to control that, and something is very, very picky about how you send those signals. Whether the pin has to be set to input or output, and you can't leave it set how you want it. You can't use a variable to, talk to the pin and this kind of thing. And it was just very, very frustrating, but we got through it and it's all done.
It was about half a day of troubleshooting.
Yeah, it was really annoying.
And then we did figure out the wireless thing by using the hardware thing. And this is just an example of the little micro switch that goes in the pedal now to trigger the whole thing.
Very nice. That's much better.
I got that from my camera days. So, it was a lot of sourcing, a lot of work, and I have to thank Jeremy for helping me out with all this because it wouldn't be at this level.
Thanks for letting me help out with this because, as I said, it was a pleasure given the amount of work you had put into this and how neat you were with the wiring, how little I had to do. It was very refreshing. Thank you.
Why, thank you.
Awesome. That was really entertaining, really educational.
Thank you.
And the finished product is beautiful. Sean, you outdid yourself. So for people out there, this kit is actually available. You can actually, we'll have information below about where you can find Sean's kits, the files, and also the code that Jeremy worked on to make your own ghost trap. I do want to thank Dremel for giving us this opportunity for Sean to design and build out this ghost trap. And we'll have more on this project and other projects in the future on Tested. Subscribe to our YouTube channel, and we'll see you guys next time.